Hi, my name is Gavin Kimmel, and I chose to examine the relationship between socioeconomic status and the soil macronutrient levels of public parks throughout different neighborhoods in the Twin Cities. So, the importance of community green spaces has recently been recognized by academics, government officials, and city residents alike. These designated natural areas, often within urban settings, increase environmental and personal well being, along with the overall improvement and beautification of the surrounding neighborhood. Here you can see an example of a local one within the Twin Cities. However, when designing these green spaces, soil quality must be taken into consideration. While it has been found that lead, arsenic, and other toxic chemicals are more prevalent in the soils of urban, low income communities, very little work has been done regarding the components of the soil that actually support plant growth instead of harming it. So, to observe the naturally beneficial components of soil, I decided to look at the soil's macronutrient composition. There are 16 essential elements needed to grow plants, but the three main macronutrients that are required for healthy, sustained plant growth are nitrate, nitrogen, phosphorus, and potash, otherwise referred to as NPK. In my study, I examined how the median household income of neighborhoods throughout the Twin Cities might impact the NPK levels within the community's soil. I chose median household income as my variable because it is measured by the United States Census and is therefore a commonly used variable to represent the greater socioeconomic status of a certain area. To pursue this project, four Twin Cities neighborhoods with varying median household incomes were chosen, and soil samples were collected from three public parks within each area. The samples were tested for their NPK concentrations, and then a potential relationship between median household income and macronutrient levels was determined statistically. However, it is unlikely that any significant relationship between the two will be found, since most of the factors behind soil NPK deficiency, things like crop removal, lack of organic matter in the soil, and runoff, cannot be attributed to socioeconomic disparities in the way that, say, lead pollution in the soil could come from an unregulated factory in a lower socioeconomic status community. Therefore, it was hypothesized that the median household income of a neighborhood in the Twin Cities will have no impact on the NPK levels in the soil from public parks in that community. However, this project was still worth pursuing in case an unjust relationship was found. For example, if communities with lower median household incomes also had lower NPK levels, this would have to be taken into consideration and compensated for when designing green spaces for that neighborhood. To begin pursuing this project, soil samples were collected from three public parks within four different Twin Cities neighborhoods. As you can see here, these are the four neighborhoods, and these are the three parks per neighborhood. These colors correspond with the following map, where the highlighted area is the neighborhood, and the stars are the parks. At each park, three site-specific samples were collected using the Lamott five-point method for soil sampling, which you can see here. Five individual samples are collected, then mixed together to form a site-specific composite sample. To provide an extra measure of consistency, samples at each park were taken next to a paved sports court, in a field that was not being visibly being used for athletic activity, and next to a tree with a 10 to 12 inch diameter. A tree that large was chosen because a tree of that size would be surrounded by soil that had been undisturbed for at least 50 years. Additionally, only the top 10.65 centimeters of the soil was collected for testing, as that is within the recommended range for collecting and testing untilled land. After air drying for around 12 hours, each soil sample was then tested for nitrate, nitrogen, phosphorus, and potash concentrations using a Lamott soil macronutrients test kit. So before I brought socioeconomic status into the mix, I wanted to determine if location within an individual park impacted the sample NPK levels. So to determine that, all three site-specific soil samples from one park in each neighborhood were tested for their macronutrient concentrations. Then a one-way ANOVA was run for each park to test for differences in macronutrient concentrations between the three site-specific samples, but no significant variation was found, meaning that the p-value was greater than 0.05. It was then assumed that a similar insignificance would be found across all the other parks that were sampled from, so the three site-specific samples for all the other parks were combined into a single composite sample for each park. To better explain that, we can go back to this table. For four parks, one per neighborhood, All three site-specific samples that were collected were tested for their macronutrient concentrations. Then a one-way ANOVA was run to determine potential variation between locations in each park, but no significant p-value was found. Once that insignificance occurred, all 8 other parks had their 3 site-specific soil samples composited together into one sample per park. Once these composite samples were tested, a linear regression was run using the data to determine a potential correlation between median household income and soil NPK concentration. So here are the 3 linear regressions per macronutrient, along with the correlation coefficient, R-squared value, and p-value. Now, as you can see, all 3 p-values are insignificant, meaning that they are greater than 0.05. This means that within the Twin Cities, no significant correlation between socioeconomic status and the soil macronutrient levels was found. The results of my study support the hypothesis that median household income does not have a significant correlation with soil macronutrient concentration within the Twin Cities. However, there is value in continuing to analyze the NPK concentrations of parks, as creating a well-sustained community garden can be difficult. Each plant requires a different level of macronutrients, and it must be ensured that every community and neighborhood understands how to support these nutrient-specific plants. Generally speaking, vegetables require higher levels of NPK, while fruits require medium to low levels. So, while most healthy, non contaminated soil would be able to support some sort of greenery, it must be ensured that every community understands how to work with their local soil and has the resources to do so. Fundamental continuations of this study would involve including more neighborhoods and testing each soil sample multiple times so that each declared quote unquote macronutrient level is actually an average of multiple trials. More neighborhoods also means more data points, which would help to solidify and expand upon my findings. Additionally, while testing nutrient levels in the lab is an effective way of passively demonstrating the soil quality, it should be investigated how the soil from these parks are or are not capable of sustaining plant life, as this would expand beyond soil tests by demonstrating the macronutrient levels of the soil in practice. Here are my references, and thank you so much for your time.